All right, guys, this is a video about exercise 933. So we're going to start off by talking about inverses of a function. Particularly in this case, we're going to talk about the inverse of both a square root and a square function. So for example, when I look at this problem on the example, right, and it's really asking me to find the inverse, there's a couple of things that I'm just trying to remind you, right, that we've done in the past. If I were drawing this, right, if I were to ask you, hey guys, what do you notice about this graph? Like, what do you know about it? Hopefully you would tell me that that means to the right 2. So this would be a parabola, right? Parent function is x squared. And this is down 3. All right, so again, to the right 2 and down 3. So the vertex of this point right here would be 2, 3. And yes, I didn't make a mistake. I did say to the right 2 because remember, if it's inside the parentheses, it's going to move it right or left, and it's always the opposite of what you think. Now, remember, if you can't remember, right, not to be mysterious about it, but if you set that equal to 0, you get x is equal to 2, so that gives you the x coordinate of the vertex. So anyway, this would look something like this, right? This is just a sketch, it's not perfect, of course. So it's just some kind of parabola that looks like that. Now, if I ask you to find the inverse, right? The inverse, if you're just looking at the graph, and you would draw this line is the line y is equal to x. Then the inverse will be a reflection over that red dotted line that I just drew. So again, the inverse is a reflection over the y equals x line. So let's see, and also another thing you should remember is that the inverse, like they would have opposite, or the x and y values would be reversed. So the vertex of the inverse function would be 3, and by the way, this is negative 3. Just notice that. So this would be negative 3. And let's see, excuse me, negative 3 would be 1, 2, 3, and then up 2, so it'd be somewhere over here. So let me draw in a different color here. So that would be this parabola. And of course, I'm not doing a great job of this, but because if I did, I think I should go right through this line. I think I could be wrong, so it's not perfect, of course, but it would look something like that. So it would be a reflection over that line. Now, what they're going to ask you to do eventually, and I'd rather just cover it now, is they're going to ask you to do something called restricting the domain. So hopefully what you notice is that the inverse function, remember the yellow curve over here is the inverse function, all right, is not actually a function because it fails the vertical line test. Remember, the vertical line test says that basically if your x value, if one x value gives you 2 different y values, in this case, a vertical line crosses 2 points, then it's not a function. So again, my inverse relation here is not a function. So to make sure that my inverse is also a function, what they're going to make you do is to restrict the domain. So if I restrict the domain, so let me go back to this same exact problem that we just talked about. What they're going to do is they're going to restrict the domain to x is greater than or equal to 2, meaning they're only going to graph this side. And if they only graph that side, I remember this would be the line. It has to be a reflection over this line. Then my inverse now is a function. All right, so sometimes that's called restricting the domain, and that's what they're talking about here. So restricting the domain just allows the inverse function, the inverse relation to actually be a function. All right, so let's go to something a little bit more tangible now. If I ask you to find the inverse, right, now they write the steps here, and I don't mind the steps, I just happen to do it differently. So I always tell kids the same thing. I want to switch the x and y value. And when I say switch, I literally mean I'm going to replace the y with an x. Right, so I'm going to say switch x and y. And I'm literally going to replace this x right here with a y. Y minus 2 squared minus 3. And then to find the inverse, all we have to do is solve for y. Right, so notice what we're going to do is we want to isolate the square function. In this case, so don't FOIL, that actually would make it harder for you. So we're gonna start off by adding 3 to each side, and this will leave us with y minus 2 squared. And by the way, the steps on the left side are basically the same right now. To get rid of the square, I would have to take a square root. And remember, don't forget what we're doing. We're solving for y. I'm trying to get y by itself. Now, when I take the square root, I actually get a positive and a negative, x plus 3 over here. And this would just be a y minus 2. Now, if I am asked to restrict the domain, then I wouldn't really have the negative. And that's normally what happens, okay? And then finally, as I'm solving for y, I'm going to add a 2. So my final answer would be y is equal to the square root of x plus 3 plus 2. Okay? And if you see this symbol right here, which is what they have right here, the same symbol, this symbol just says that that's the inverse. So that's the symbol for the inverse function. All right, so this will be the inverse. All right, that's it for that. Let's go ahead and move on here. Now this exercise, right, this is a little bit of an exercise stuff we've done before. They want you to eventually graph it, so let's just talk about it. Remember, inside of that, if you set that equal to 0, whoops. If you set this equal to 0, you get x is equal to negative 4. Okay, so now that means that's going to be to the left 4, up 1, and then this right here is the negative represents a so again, the negative, not the 3, but the negative represents a reflection over the x-axis. You don't have to necessarily write all that. But the 3 represents a vertical stretch by a factor of 3. I'm just going to write by 3, but normally it's by a factor of 3. Now they're going to ask you for the domain. Now I would like to actually talk about the domain before actually drawing the graph, because when it comes to domain, no matter what the graph is, what you really want to think about, remember the domain is a set of all x's, right, that the function can take over. Now, meaning that's when I say how far to the left, how far to the right, but when I can't see the graph, you have to think of what x cannot be equal to. For example, if we talk about rationals, right, like if I had something like this, if I want to know what the domain is without actually graphing it, all I would have to do is set the denominator equal to 0. And you might be thinking, well, why would I do that? Oops, excuse me. Why would I do that? Well, because I know that if the denominator is 0, I cannot divide by 0. So that's actually gives me my domain. So in this example, if x is negative 4, right? In this example, if x is equal to negative 4, my domain will be x cannot be equal to negative 4 because negative 4 would make it a 0 in the denominator. Now, as far as the square root, okay, you have to think about what numbers can I not take the square root of and get a real number, right? So hopefully, again, what are the numbers that you cannot take the square root of and get a real number? So for example, the square root of any negative number would be imaginary. So I cannot have any negatives inside the square root. So in order to assure that that happens, all I'm going to do is just take the x plus 4. I'm talking about this x plus 4, by the way. The inside of that square root has to be positive. And positive would mean that x plus 4 has to be greater than or equal to 0. So if I solve for x, I would get a negative 4 like that. And when I finally get to actually draw it, you will see that that's actually exactly what happens. Now, we'll wait on the range. Remember the x-intercept means that you set your y value is equal to 0. All right, so if I set this equal to 0, and by the way, and I understand that I'm writing really small, okay, so do the same here. So if I set this equal to 0, remember we're going to do the same steps we did in the previous lesson, which is we want to isolate the square root. Now, at this point, you have a choice, right? And your choice is I can divide both sides by -3, or I can go ahead and square both sides like it is if you don't want to deal with the fraction right now. Eventually, we're going to have to deal with the fraction, but this might be easier for most of you. Now, when I square the left side, I get 9x plus 4, because I square the -3 and I square the square root, and the -1 squared is just 1. Right, I can then distribute this 9 and then solve for x. So this would be a -39, -35 over 9. So my x-intercept, which is not pretty, is -35 over 9, which is almost 4, like that. Now my y-intercept, remember, we're going to set x is equal to 0, and for that is much easier. I'm going to plug in a 0 for x. That would give me the square root of 4. The square root of 4 is just 2. 2 times 3 is 6. So this answer would be -5. So my y-intercept would be 0, -5. All right, now it wants us to sketch the graph for that technology, so let's talk about that, and then we'll talk about the range. Remember, since this has a square root, that means that the parent function, square root of... My apologies, that seems way longer when it's on video. Since this is the square root of a linear function, all right, the parent function is this one. And you should at least be able to come up with the numbers for this, right? Technically, you can pick any x, but this would be the easiest ones. Because the square root is 0, 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. All right, so I'm going to first, remember I said that it was left 4 and up 1. This is, what the heck? This is what I call my fake origin. All right, so I'm going to pretend like that point right there is 0, 0, though I know it's not. Okay, I know for a fact it's not, but I'm going to pretend that it is. And then if you want to get the vertical stretch and the reflection, all you have to do is multiply that times -3. All right, so if you multiply the y by -3, all you have to do is multiply only the y values by -3. So this point right here that I'm about to write, let's see, 0, -3, excuse me, 1, -3. That's what would happen if this number right here and this y value would be multiplied by -3. So technically, this point would be 1, -3. Though I know it's not. Okay, and then finally, the next point that I can graph would be this one, which is 4. And if I multiply that -2 times -3, that would give me a 4, -6. All right, so this would be -6. This was -3. So that point actually would be right there. No. Oh, excuse me. That's what this would look like, okay? All right, finally, let's talk about our range. So you can kind of see it now. What is the highest y value? Now, the actual y value of this one. Right, again, the actual y value of this one was -4, 1. That's the highest y value, and the lowest y value would be -infinity. So I can write this either as -infinity to 1, including 1, or you can write it as y is less than or equal to 1. All right. So hopefully you remember all that. That's just sort of a review of stuff we kind of done in the past, except I don't think we did it with the square root. Now, let's talk about these, right? And for these, I'm actually going to go to a separate piece of paper to do them. Now, all they want you to do is to state the transformations, meaning up, down, left, right, stretch, or not. All right, now, on number 6, hopefully you notice something kind of weird. The fact that you normally don't have a 4 here. But what we can do to get around that is that we can factor a 4 inside the square root. And when we do that, I can actually rewrite that. I can take the square root of 4, which is 2, and I can write that as x minus 1 in here, right? So all they want you to do on example like number 6 is all they want you to do is say, okay, that's going to be up 9, and then to the right 1, and then vertical stretch by a factor of 2. Okay. Now, that's what I want you to do. Now, if it has a cube root, really it doesn't change the way you write this. So, for example, that one right there, number 9, would be up 3, and then a reflection over the y-axis because of the negative in front of the cube root. Over x-axis. Okay. That's that for that. Now, what I'm actually kind of interested on is see if you can remember how to do 10 through 12. I don't think I'm going to go through all of them just because I want to give you something to work on because we don't have a homework for this, right? So I'm going to do number 10 and number 12 and see if you can do 13 on your own. Okay, and then we can go from there, right? So let's let me actually write it on here, though. You probably need a separate piece of paper for this because it does take a little bit. So let me see here. Let me see if I can write it here somewhere. So we have 9. Sorry, I'm writing it separately here so I don't have to turn back on my iPad. Okay. And number 8. Okay. Looks like this one I have done already, but let's pretend I didn't do that before. All right, so on this one right here, right, the first thing to do is to switch the x and y. Right, so notice that I already did that. All right, so I already switched. Normally, I would have, normally I would have here a y, this normally is f of x. And normally this right here would be a x value. But I went ahead and switched them, right? So remember, that's the way to solve for the inverse, which is what it's asking me to do. Now, what I can do now is first, I need to isolate the radical. So we're going to subtract 9 from both sides. We have the square root here. Remember, I'm solving for y, so how can I get rid of the square root? We can square both sides. And though I could FOIL this, I am not, all right? Specifically because if I'm trying to graph this down the line, I got to be able to read it. And if I FOIL that, that's going to be pretty hard for me to know what this looked like, right? But anyway, so now we're going to subtract the 4. Excuse me, we're going to add the 4. And then finally, we're going to divide both sides by 4. Now, if I ask you, hey guys, I need you to tell me all the transformations, I think that over 4 makes it a little bit more difficult. So what I would do if I was forced to either graph it or tell you the transformations, I would divide each thing by 4, knowing that this could be rewritten like this. And if I write it like this, hopefully you can follow that. Notice that this is a whole lot easier to figure out what I'm talking about, right? So this is vertical compression of 1/4 to the right 1 up 9, and remember this is the inverse, right? Which normally they require you to write this symbol for the inverse, but the function wouldn't change. Okay, finally, let me do number, I don't remember what number this was. I think that was 12, though I could be wrong. Let's see, 9 plus 2 cube root of x, y is equal. So this is a separate problem here. Let me go back to the notes. Let's see if that's actually true. 9 plus 2. Okay, yeah, so it's 9 plus 2 cube roots of x. Now, we're going to start off by switching the x and y. Don't forget, that's step number 1. And we're going to solve for y. So hopefully you can see that we're going to subtract 9. And then at this point, you have 2 choices. If you want to divide by 2, you can. The other choice is just to go ahead and cube both sides. Either way, if I cube all of this, right, because I'm trying to get rid of the cube root. So to get rid of the cube root, I would have to cube both sides. Right now, when I cube both sides, I can actually rewrite it like this. And yes, I do not want you to actually expand that, because that would actually be counterproductive at this point. So my final answer would be x minus 9 cubed over 8, right? Okay, so that would be the inverse. So at this point, guys, I would say try to do 14 through 17, right? And notice that all you're doing is, first of all, it's asking for the domain, it's 1-to-1 and decreasing, so non-decreasing. Okay, so it basically wants you to do the right side. So before you actually do any of the inverses, they want you to actually go, let's see, this one's 4. They want you to only graph this part of the right side of the parabola, not the left side. Right, so the right side would be x is greater than or equal to 4. So that's the restricted in the domain. And then at that point, I need you to just find the inverse, right? So see if you can find the inverse for 14 through 17 before part 2 of this lesson, which is when we're going to talk about 18 through 23. 18 through 22, really. Okay? Well, that's it, guys. If you have any questions,